for day 9 notes, which involves interest problems. So you guys probably know about interest. If you put your money in the bank and you leave it there, all right, you make interest. All right, so there's 2 types of interest. There's simple interest and compound interest. All right, and why we're talking about these in this chapter is these are actually exponential functions. So I just want to remind you, exponential functions can be written in the form y equals a times b to the x. All right, so interest is going to be an exponential function. All right, and your simple interest or your annual interest, basically if you put your money in the bank and you only got interest once a year, you got it annually. All right, the formula is going to look pretty similar to our exponential function. All right, it's going to be y equals a times, instead of the b, we're going to rewrite it as 1 plus r to the x power. All right, so that should look pretty familiar to you. All right, we've already said that you can write an exponential function with this b value, or you can kind of split it into 1 plus r or 1 minus r. All right, so simple interest formula looks identical to, the exponential functions we've been talking about. All right, let's just talk about what each of these variables represents when we're talking about interest. All right, A is going to represent your initial investment. Say if initially you're putting $500 in the bank, all right, that's the initial amount of money. That's your A value. All right, R is going to be your interest rate. All right, sometimes you might go to Chase Bank and they'll tell you, you have a 1% interest rate, something like that. Only thing is, in the formula, the R always has to be a decimal. All right, most of the time, they're going to give you R, the interest rate, as a percent. It's up to you to change it to a decimal. All right, and X is going to be the number of years, right, that you leave your money in the bank for. All right, so say if initially you invest $1,000 at an interest rate of 1% and you plan on leaving your money in the bank for 10 years, all right, if you plug in all those numbers into this formula, you can figure out how much money you would have at the end of 10 years. All right, so that is simple interest. Getting that interest once a year. All right, then there's something called compound interest, where sometimes you get the interest more than once a year. All right, sometimes they tell you that your interest is compounded quarterly, which would mean you get the interest 4 times a year. It could be compounded daily, meaning you get the interest every day. All right, it could be compounded monthly, meaning you get the interest every month. All right, and this formula looks a tiny bit different. All right, it is going to be y equals a 1 plus r over n to the nx power. All right, so again, let's talk about what these variables mean. All right, basically the same formula that we have above. The only difference is the addition of these n's right here. All right, and we'll talk about what those mean. So, our A value right here, all right, is still your initial investment. Say if initially you're going to put $500 in the bank, all right, R is still your interest rate. But of course, if you're plugging it into this formula, it must be in decimal form. Most of the time, when banks are advertising, they'll give you a percentage for your interest rate. You have to change it to a decimal. All right. N is going to be the number of times the interest is compounded per year. All right, so say if they tell you, that the interest is compounded quarterly, there's 4 quarters in a year, N would be 4. You're getting that interest 4 times a year. All right, if they told you, the interest is compounded daily, think about there are 365 days in a year, your N would be 365. And if they told you, your interest was compounded monthly, there's 12 months in a year, so N would be 12. All right, and lastly, X is the same as before. It's just the number of years that you plan on leaving your money in the bank for. So those are kind of our two formulas. Again, they're really the same thing, just kind of with the addition of the N. Katrina invests $1,000 at an annual interest rate of 12%. What is her account balance after 1 year if it's compounded annually and monthly? All right, so we're comparing. And something to point out before we start, all right, just a vocab word that you might see in our textbook. All right, this annual interest rate of 12% is sometimes called the nominal rate. All right, I like to think the nominal rate is basically what they advertise. All right, they're advertising that you're getting 12%, but you might actually get something different. If you're getting 12% every month, are you really getting 12%? So just know the nominal rate is basically what is advertised in the problem. All right, but sometimes you have to be smarter than that. If you're comparing banks and they're both giving you an interest rate of 12%, but at one of the banks, you're getting 12% annually, once a year, and at another bank, you're getting 12% monthly. All right, you need to know which one is the better option to go with. All right, so first one is compounded annually. All right, so that's going to be our simple interest formula or annual interest formula, y equals a 1 plus r to the x power. All right, and the second one is compounded monthly. So monthly is our compound interest formula, this one. So it's y equals a 1 plus r over n to the nx power. All right, so we need to plug everything in. All right, this 1,000 is our A value. That's how much she's initially investing. All right, the 12%, that's the interest rate. But again, to plug it into our formula for R, you got to turn it into a decimal. It's going to be 0.12. All right, what is her account balance after 1 year? We said X is the number of years, so that's our X value. All right, so let's use that. All right, we have Y equals 1,000, 1 plus 0.12 to the first power. And if you want to clean that up, you can, or you could type it in your calculator right away. This is really 1,000 times right here. You can add these together, 1.12. If you're raising something to the first power, you probably don't even need to raise it to the first power. So it would just be 1,000 times 1.12. And you'd get 1120. Or in other words, $1,120. All right, so think, she was investing the $1,000. She put it in the bank for a year. All right, she made an extra $120. So not bad. All right, let's talk about another vocab word. All right, we mentioned this word, the nominal rate, up here. Oops. Just trying to get a pen. We mentioned the nominal rate is basically the rate that's advertised. All right, they advertise that you get 12%. All right, then there's something called the effective annual yield. All right, which is the percent you actually get. All right, sometimes they advertise the nominal rate and what you actually get is a little bit different. All right, the effective annual yield here, what you actually turned out to get, all right, is really also 12%. All right, all we were getting was an extra 12%. So in this case, the effective annual yield, all right, was 12%. All right, which should make sense. If they advertised an annual interest rate of 12%, all right, and you're only getting that annually once a year, you're getting the 12% once a year, there's really, no gray area there. They're advertising 12% and you got 12%. All right. Whereas over here, it might be a little bit different. If you're getting that 12% every month, is it really 12% or is it a little bit more? Think about there's 12 months in a year. If you get 12% 12 times, what does that really turn out to be? So let's see that. All right, let's plug in what we know. All right, A is what initially was invested, the 1,000, 1 plus 0.12. All right, our N here, we said N is the number of times, all right, your interest is compounded per year. So since this is monthly, think how many months in a year? 12 months in a year, N is going to be 12. So divide by 12, and raise it to the 12 times x power. We said x is 1. All right, so let's just try to clean this up. We've got 1,000 times, I would put all this in your calculator at once. All right, you probably don't need the 12 times 1. 12 times 1 is just itself. So let's try to put this in your calculator. If you have an old calculator, all right, make sure you put this part in parentheses so your calculator knows that's a fraction. So practice typing that in with me so you know if you're doing it right or wrong. If you type that in, you should get 1.1268. I'm going to go with 4 decimal places. All right. From here, you can see what your effective annual yield is. All right, we talked about in this problem, 12% was advertised and we actually got 12%. All right, in this problem, if we just look at this decimal part, ignore the 1 at the front. All right, if you just look at the decimal part, the effective annual yield, the percentage that you actually get, is 12.68%. All right, so that's good to know that in this case, we're getting a little bit more than 12%, which should make sense. All right, to finish the problem, we're going to multiply those together. All right, and you should get 1126.83. If you round to 2 decimal places, we're talking about money. All right, so if you compare those two, the first one, you got $120 extra, basically. That was the interest. Here you get about $126. You do make a little bit more, which again should make sense. They both had, an interest rate of 12%, but if you're only getting the 12% annually, in once a year versus monthly, if you're getting the 12% 12 times a year, the more often you get it, the better a deal it's going to be. All right, so let's look at number 2. An annual interest rate of 6%. What is the account balance after 5 years? All right, if it's compounded monthly. All right, so think compounded monthly, all right, means 12 times a year. All right, compounded monthly. We're going to use this more complicated formula right here. All right, our compound interest formula. So let's write that down. Y equals A, 1 plus R over N to the NX power. All right, so 1,000 is going to be our A value. Our interest rate, R, is going to be 0.06 if we turn that to a decimal. What's in the account after 5 years? X is going to be 5. And if it's compounded monthly, all right, monthly means N is 12. So we could plug those numbers in. We have Y equals 1,000, 1 plus 0.06 divided by 12 raised to the 12 times 5 power. All right, so if we clean this up a bit, again, we can type all this into our calculator at once. All right, I would just be careful, especially if you have an old calculator, put this in parentheses and probably put this exponent in parentheses too, that 12 times 5. So I would practice typing it in with me. A lot of kids make mistakes when typing this in. All right, you should get about 1.3489, I'm going to go with, if you round to 4 decimal places. All right, I always write this step in. I don't multiply it all together. I don't include the 1,000 right away, just because I think in the book and on the homework, they're going to ask you, what's the nominal rate? All right, and what's the effective annual yield? That will be part of the problem. I know our problems didn't ask that specifically here, all right? But if they ask those questions, again, nominal rate is just what's advertised, what the problem says, all right? The nominal rate is that we're getting 6% interest, all right? But what are we really getting? If you look at just this decimal part, not the 1 in front of it, and turn that into a percent, we get 34.89%. So even though they're advertising 6%, you're getting way more than that. All right, and think about why that is. You're getting 6% compounded monthly, so 12 times a year for 5 years. All right, I mean, just think about 6 times 5. If you get the 6%, for 5 years, 6 times 5 is 30. It should make sense that the effective annual yield is around 30. It's a little bit more than 30 because, again, you're not just getting it every year, you're getting it monthly, every month, 12 times a year. All right, so that's kind of the whole point of that step. And then the last part is actually multiply everything together to see how much money you'd have at the end. Multiply that by 1,000, you'd have 1348.85. Right. Let's take a look at example 3. At an annual interest rate of 6%, what's the account balance after 6 months if it's compounded quarterly? All right, so quarterly means 4 times a year. That's that more complicated formula. All right, so it's y equals a, 1 plus r over n to the nx power. All right, so the 1,000 is going to be our a value. The 6% means r is 0.06. The account balance after 6 months. We said that the x, all right, if you go back to what does x represent? All right, x is the number of years right here. And of course, it won't let me underline it. Yeah, x is the number of years. All right, you can't just switch that up to, days or months or whatever it is. You have to stick with years. All right, it's the correct unit. So think 6 months is how many years? It's half of a year. So that might throw people for a loop there. All right, and then compounded quarterly. Quarterly happens 4 times a year. So that means n is 4. All right, so if we plug everything in, we have y equals a, 1 plus 0.06 divided by 4 raised to the 4 times 1/2 power. All right, so, and I forgot to put the a in. The a is, of course, 1,000. All right, so our next step, again, would be to type all this into your calculator. All right, be careful if you have an older calculator like me, you may want to use extra parentheses here so your calculator really knows what's going on. I would practice typing it in with me just so you know if you're doing it right or not. You should get 1.0302 if you round to 4 decimal places. All right, remember the whole point of this step is I like to look at the decimal, change it to a percent, 3.02%. Right, is that effective annual yield, what you actually end up getting. All right, and again, I think on the homework and in the book, they ask you to compare the effective annual yield, the percentage you actually get, with what was advertised. The 6% was what was advertised. That's called the nominal rate. All right, and think you're actually getting less. You're getting about half, which should make sense. All right, if that's your annual interest rate, 6% is what you'd get in a year. If you're only leaving it in the bank for half a year, you're probably going to get about half of that. All right, half of 6 would be 3. You're getting a little bit more than half. All right, then if you wanted to know how much money you'll actually have, after that half of year, you could finish multiplying that out and you'd get 1,030.23. Let's take a look at example 4. Dollars in an account paying an interest at a nominal rate of 4% per year, compounded quarterly. By what factor does P grow in 3 years? All right, so for some reason, they're not telling us the amount that Kevin is depositing, so we must not need to know it. All right, but think about what formula we're going to use. They said compounded quarterly. All right, so that's 4 times a year, so that's that more complicated formula. Y equals a, 1 plus r over n to the nx power. All right, and it said Kevin deposits P dollars. So I guess P in this case, all right, is our A value. If you want to change it, they're calling it P. All right, 1 plus our R value, nominal rate, what they're advertising is 4%. So that's 0.04. Compounded quarterly means n is 4. So divide by 4 and raise it to the 4 times 3 power because he's going to leave it in the bank for 3 years. All right, so really what we need to do is just type this part into our calculator, all right, and see what we get there, just like we've been doing. All right, really the initial value doesn't matter. So if we type that into our calculator, again, be careful. You may want to use extra parentheses. All right, and again, if we get 1.1268, I strongly suggest rounding to 4 decimal places at this point. All right, that's the number we're looking for. All right, when they want to know what factor does P grow by, basically the initial investment, this is that number. All right, so we can say that P grows by a factor of 1.1268, all right, after 3 years. So just think about why that number would be helpful, all right? Maybe someone doesn't know, how much they want to invest in this bank account. Sometimes people divvy their money up. They put some in the stock market, some in the bank. They put it different places. So maybe they're trying to decide, well, what's that number, that factor that it grows by? And then they could test a bunch of numbers. They could say, well, what if I invested 1,000? Put 1,000 in for P. What if I invested 10,000? Something like that. So that's why that number can be helpful. All right. Think about some things that they didn't ask. They just came out and used that vocab word, nominal rate, at the very beginning. Again, nominal is what is advertised, right? 4%. All right. If they asked what was the effective annual yield, all right, or in other words, what did you actually get? They said you were going to get 4%. Well, what did you actually get? Well, you just look at the decimal part right here. Turn it into a percent, 12.68%. So that seems like a lot more than what they advertised. They advertised 4%. You got more like 12, which should make sense. If it was in the bank for 3 years, think 4 times 3 is 12. It should be around 12, but you do end up getting a little bit more than 12 since it was compounded quarterly and you got that interest 4 times a year. All right, another vocab word to know, I think our book uses this as well. Effective annual yield can also be referred to as the annual percent yield. All right, sometimes they call it APY. So just think nominal rate is what they advertise. All right, effective annual yield is what you actually get. And actually, maybe I should take out the word annual. This is just the effective yield, all right, or the percent yield here, because this is not talking annual. Annual would be once a year. We're talking about in 3 years. All right, but they just kind of use different phrases in the book, but anything like effective yield, percent yield, think yield is usually what you get at the end. So just kind of, those are vocab words to know. Let's take a look at example 5. It says, what is the effective annual yield if a deposit of $2,000 grows to $7,000 in 15 years? All right, so here they really didn't tell you which formula to use. All right, is it simple interest if we go back to our formulas? All right, or compound interest? They did mention the word annual at one point, all right, in the problem. So I would use the simple annual interest formula because they use that. What is the effective annual yield? They really want to know what you're getting in 1 year. So that formula should be y equals a, 1 plus r to the x power. Right, and they're saying a deposit of $2,000, we're starting out with $2,000, right, is growing to $7,000. They're telling us what we have at the end. Normally we don't know what's at the end, but we do here. All right, 1 plus r, we don't know the r value, but we're going to leave it in the bank for 15 years. All right, so here we can solve for the r, and that'll be our interest rate. All right, so think we need to work on getting r by itself. So what I would do first is I would divide both sides by 2,000. On this side, we get 7/2 equals 1 plus r to the 15th power. I think the next step is we want to get r by itself. Take the 15th root of both sides. So we end up with 1 plus r. Then on the left side, if we type that into our calculator, 15th root of 7/2 is about 1.0871. Right, and then if we just subtract 1 from that, you get 0.0871 is our R value. All right, so your effective annual yield would be the percentage you get in a year. All right, that would be your R value. So we just have to turn it to a percent. It would be 8.71%. And that's what they wanted to know there. All right, I hope you guys found these notes helpful. If you have questions, definitely reach out to your teacher. Otherwise, you can get started on the homework for tonight. Have a good day, guys.